Vision AI is a promising technology that's not living up to its hype. Teams are getting caught in pilot purgatory as they struggle to migrate from MVP into production. The reasons for this are threefold. The first, the sheer amount of effort that's required to build and maintain a custom dataset for such an advanced application seems insurmountable. The second is that machine learning teams only get feedback on their ML approach when deploying the model, and that's far too late. Which leads to the third, there's a lack of tooling and best practice processes when building, maintaining, and deploying your machine learning application. So how do we help with that? We built Hasty to train the model while you label. We use that model to automate 90% of the manual work. The additional benefit for machine learning engineers is that they can use that model's feedback to adjust their approach or validate their approach. Now with NVIDIA TLT, you can take a model from an adjacent use case that's been pre-trained and use that on your application to jumpstart your learning. The end result is that you've given your model the steepest learning curve possible. Our goal with Hasty is to take you from having an idea in the morning to deploying that model into production that very afternoon. We've brought the relationship between the model and the training data close together as the two are symbiotic. The result is that you'll get to a more robust solution sooner. Today's machine learning production flow resembles waterfall development. We know from software development that the process is bad at adapting to new information. Similarly, in machine learning development, the waterfall process is bad at adapting to feedback. Having a flow that is not geared for feedback loops blocks you from incorporating new data insights. This is why at Hasty we have turned this into an iterative process where practitioners can bounce between tasks as needed. You cannot control where relevant feedback will come from, so you should have a process that can action it as and when it arises. Machine learning engineers have had to stitch together a Frankensuite of tools, which means they spend more time maintaining that Frankensuite than building the actual application. Setting up a project is fast and easy. Create your project, define your classes, upload your images via drag and drop or our API. If privacy is important to you, you can even mount your external storage like AWS, Google Cloud or Azure, so that there's no permanent external storage of your images on our service. You can even upload past annotations, and from there we take care of the rest. Even though Hasty is used today across the board, from agriculture to logistics to medical and manufacturing, for the sake of this video, we'll look at an autonomous driving project. To jumpstart the automation, you can select a pre-trained model from the NVIDIA TLT library. Hasty will use that model as a base and update as you label your data for your project. We have 3 levels of automation in Hasty. With level 1, we automate labeling a single object and image. With level 2, we automate labeling an entire image. With level 3, when we see level 2 is working well, you can use that same model to batch process entire datasets and label your whole dataset. We have an array of level 1 automation features that help speed up labeling single objects in an image. The choice tools in Hasty for this are Dexter and GrabCut. With both tools you can create complex masks for an object with just a few clicks. With Dexter you simply need to click on the north, south, east and west of an object and the neural network looks for the mask. You can add points to improve the suggestion. For GrabCut you select the area where the object is and remove regions with markings to improve the results. After 10 images, we update your model with your custom data so that you can use this model to label the image. This model constantly retrains and improves the suggestions as you go. When your custom model is ready, the IS icon on the left will activate. This means that you have upgraded to level 2 automation. Generate the masks on image by clicking the icon or using the shortcut I. Adjust the confidence interval for the best results. Accept the good masks one by clicking on them, or simply press enter to accept all the suggestions. You can then edit the masks where the annotations were slightly off. This human-in-the-loop approach allows you to fine-tune your model by labeling data. Now you're labeling an image in seconds instead of minutes. At this stage of the project, we typically see a 7 to 12x increase in the number of images you're able to process in a day. The great part is that your machine learning engineers can track the performance improvements to answer questions like, is your annotation strategy working? How many images do we need to label? Which classes are proving to be a challenge and should we get more images of? Where are we getting false positives and false negatives? Does the data we added increase or decrease our model's confidence? We look for key user behavior, as well as track important model metrics to see when the models are working well in your use case. Once there, we activate fully automated labeling. where you can batch process full datasets with your custom model to label new images. We will show you a sample of the images being automatically labeled before you hit go, so that you have confidence that you're getting good results. We mark those images as automatically labeled to keep clear what was processed by the model and your team. Finally, we have an AI-powered error finder feature. This uses a carefully constructed model to find common issues in annotation. You can ask it to look for misclassifications, missed objects, artifacts, or poor outlines or masks. We show you key metrics of the suspected trouble images and provide an interface where you can review the suggestions from our model. As always, we take your corrections into account when retraining your model. So now, the result of your efforts is that you'll have a large custom training dataset. It's important to point out that all users in Hasty are looking to define their future competitive advantage. So you will retain ownership of your images and the resulting data, and only you can license the models from us.
We then give you an access to the model in Hasty, so you can play with transformations, loss functions, metrics, schedulers, try different architectures, and adjust over 100 parameters to optimize your model. We can train anything from simple classification models to extremely deep instance segmentation models, all in one place. With the NVIDIA TLT integration, a lot of the hard work is already done for getting you substantial annotation automation from day one of your project. With the multiple choices available, you can even compare different architectures and parameters to each other and see what works best for you.
We are driving the move towards more data-centric and agile machine learning development. How we do that in practice is we provide an annotation environment, quality control features, and model playground. So you can create data, fix data, and then develop a better and better model, and switch between as needed. When you get to a state when your model is production ready, you can go and deploy it, either to normal cloud-based infrastructure or to any device. For example, this desktop, this Jetson, or even this car. Because we're using NVIDIA TLT, all models are quantized and pruned, giving you state-of-the-art performance. To summarize, with our advanced tooling and NVIDIA TLT, you can finally get out of pilot purgatory and go from 0 to 100 faster than ever before.